Hello everyone, today let's solve the problem Knapsack, right? So this was asked in the educational code forces around 61, right? So this is rated for the division 2. Again, this was asked for the this one, educational code forces around 61, right? So rated for the division 2, right? So let's solve this problem. So I can just go through the problem. It is very easy to understand. So I'll just summarize the question so that it will be easier for us to solve the problem, right? So what the question states here, we have counts of items, right? So just give me a second here, 1 second. Yeah, we have counts of items, right, of weights 1 to 8, right? So we have this one, counts of items of weight from 1 to 8. Just remember this one, right? And limit, and we have a limit as well, w. That limit is represented by w, right? A subset is good if its total weight is less than or equal to w. Again, a subset, so this one, a subset is good if it's this one, what do we call, if its total weight is less than or equal to w, is less than or equal to w, right? So we have to find the maximum possible weight of the good subset, right? So we have to find the maximum possible weight of the good subset. What do we need to find? Again, we need to find the maximum possible weight, right? So maximum possible weight, I'll just write here, right? So this one, WHT or WGT, maximum possible weight of a good subset. So this is the question basically, right? Simple. So again, I'll just read out the question loud, just listen to this carefully. So we have counts of items of weights 1 to 8 and a limit w, right? So a subset is good if its total weight is less than or equal to w, right? So this part. So what we need to find here, we need to find the maximum possible weight of the count, this one, good subset. That's what we need to find here, this part, right? So this is fine. Now let me delete this one. Yeah, let me come to the input part here. So now this one here is nothing but, what do we call, weight, right? So weight or w they have mentioned 10 here. So this is nothing but the count they have given here, 1 2 3 4 5 6 7 8, right? So this is nothing but the count. So the output that we need to get here, or the maximum possible weight of a good subset, is here 10 basically. Same goes with here, this one as well, right? So same goes with the second and third example. So I insist you to try out for the second or third. Second we have only 0, so I insist you to try out for the third example. Whatever approach that we go with, just try to implement the same thing, or just try to articulate the same thing in the form of this one code, or just try to implement the same thing whatever we'll discuss for the third example, right? So that you'll get the question correctly, or so that your solution may be better than mine, who knows, right? So first, before this one, getting into the coding part, let's discuss the approach followed by the complexities, and then let's write the code as usual, right? As usual, let's start with the approach. So I have considered the same first example within the question, right? So we have w weight nothing but 10 here. So we have counts here, this one, and output that we need to get here is 10. So to solve this problem, we'll be making use of the dynamic programming. Just remember this, we'll be making use of the dynamic programming here, right? So let's move on with the step-by-step explanation. Weight we have 10, counts we have 1 2 3 4 5 6 7 8, and total weight is nothing but adding this one, right? Just give me a second here, 1 second, not. So total weight is here 204 basically. So 204 because see here, we will be going with the square of each number here, right? So this will be we have from 1 to 8 basically, they have strictly mentioned in the question, right? So what they had mentioned in the question, just give me a second here, 1 second. The first sentence that I have said, if you remember, so we have been given counts of the items of weights from 1 to 8 and a limit w, right? So this one, total weight in the sense, we'll be going with 1 square plus 2 square plus 3 square plus 4 square plus 5 square, 6 square plus 7 square plus 8 square here. So when we sum up this one, so this will lead to 204. You can just try this one, right? 1 plus 4 plus 9 plus 16 plus 25 plus 36 plus 49 plus 64. So that will lead to 204, right? So second step is, so we will truncate here item counts for the DP. As I've said, we'll be going with the dynamic programming, right? So we'll be truncating the item counts for the DP. So we will keep at most LIM by I, items of weight I, so dp stays small here, right? So this one, when I say small, the count that will be equivalent to the 840, right? 840. For those, these small counts run bounded knapsack dp, right? For those, these small counts run bounded knapsack dp, right? So this is fine, man. I hope this is fine. For any remaining excess items after the truncation, so we will be going with a greedy approach, right? So we'll be going with a greedy. So you will understand this one while we write the code. Still, the theory part is very important here, right? So for any remaining excess items after truncation, so we will greedily take as many as possible to reach the base matrix from 0 to w minus lim, w hyphen lim, right? So we will run the dp over truncated counts to find the best additional weight, right? So we'll be going with w has to be less than or equal to w minus picked, right? So final answer will be picked plus w. So we'll be going with this formula, right? So we'll be going with picked plus w, right? So in the example, we can pick the weight, this one 8 as well as 2, right? So pick plus w, right? So this will be pick will be 8 and w will be this one 2 from the available item. So output will be 10, right? So output will be 8 plus 2, which is equivalent to the 10, right? So output that we got here is 10, which is equivalent to the output that they have mentioned for the example 1 within the question, right? So our approach works absolutely correct, right? Our approach works absolutely correct here in this case. So as we are completely familiar with the approach, we can just move on with the complexities part, right? So what will be the time complexity here? The time complexity would lead to big O of lim square, that is equivalent to the big O of 840 square, right? So we got the lim value 840, right? So this one smallest value that we considered in the approach, so this will be big O of 8 into lim square, nothing but big O of 840 square, which is almost equivalent to the 15 million, right? So this is equivalent to the big O of 1 for the constraints, which is equivalent to the big O of 1 for the constraint. So what will be the space complexity here? The space complexity would lead to big O of 8 into lim, right? So big O of 8 into lim, so that is equivalent to the almost equivalent to the big O of 6720, big O of 6720, which is almost equivalent to the again big O of 1 constraints, right? So big O of 1 constraints here, big O of 1 for the constraint. So this is about the time complexity and the space complexity, right? So as we are completely familiar with the complexities and the approach part, we are good to write the code. Let's start writing the code. I'll just come here. So we'll be making use of the fast input and output. So I'll just import the input output package, right? So java.io.star, and also we'll be making use of the different utilities as well, right? So I'll just import here utility package, right? So I'll just go with util.star. This is fine. Let's go with some class name here. Class name, I'll just go with main. You can just go with any class name that's relevant to this question, right? So let's go with the limit that is used to bound the dp size, right? So this is chosen by the this one what we call solution authors, basically in simple terms, right? So we have to go with the 840 if you remember, right? So this one will be static final in lim, so accordingly with the constraints we are going. So this one I'll just go with the 840 here. This is fine. The next step would be, let's go with the main method, right? So this is fine. Let me add here throws exception, or else we'll be getting the error. This is fine. So so within the main method, let me go with buffered reader br. So this one will be new buffered reader new, this will be input stream reader. So this is also fine, of system.n. So this will be system.n. This is fine. Let me go with print writer as well. So I'll just go with the print writer. This one will be output equals new print writer. So this one system.out. Fine. Now let's go with a string line, right? So I'll just go with a string line. So this is fine. Now let's do one thing. So we have to read until the end of this one, right? The code is written to handle the input possibly split across the lines, right? So I'll just go with a simple while loop, right? For this one I can just write it on this way. Line, how can I implement this one in the form of code? Line equals buffered reader dot read line. So this one is fine. Yep. So not equal to null, this is also fine. So we have to build a single token stream that contains at least 9 tokens. So here in this case it is w plus 8 counts, right? So I'll just go with a string builder here. String builder, this is also fine. Sp, this is equivalent to new string builder of, let me pass line here. So this is fine. Now let's go with a simple while loop. This is also fine. String builder dot to string. So this is trim. So fine. Split s plus. This is also fine. Nothing but the regular expression here. Also let me go with length if it is less than 9. As I have said, what we are doing here, so we are building a single token stream that contains at least 9 tokens. Here in this case it will be this one, w plus 8 counts. Don't get confused, and this is the regular expression, right? So this is fine, man. So within the while loop, what we'll do, first we will be reading more lines if the current line doesn't contain all the required tokens, right? So I'll just go with string here, extra, let me assign this one to the buffered reader dot read line, right? So this is fine. This is completely related to the input output, man. Don't get confused. So if you want to make use of the other template, you can just go with it. Go ahead, right? So if extra, so this is equivalent to null, then I'll just give break here, right? So we are breaking. Then let me make use of the string builder, and let's go with the append here, space. Also let's append the extra. Let me pass the extra variable here. This is fine. So let me come out of this one entirely. Now let's do one thing. Let's tokenize the collected input, nothing but w and the 8 counts, right? So I'll just go with the string tokenizer here. This one will be string tokenizer st equals new string tokenizer. So this one will be string builder dot to string. This is also fine. Now if not of string tokenizer dot has more tokens, so this one let me give continue, word continue here, right? So this is fine, man. Now let's go with this one, w, nothing but the w is nothing but the maximum allowed subset weight. We know this one from the question, right? So w has to be greater than or equal to 0 and less than or equal to 10 to the power of this one, what do we call 1e18, basically 10 to the power of 18, right? So accordingly with the constraints that they have given in the question. So I'll just go with long w equals, so this one will be long dot parse. I'll just go with long here. So string tokenizer dot next token. This is fine. Now let's do one thing. Let's go with too long, nothing but let's go with a and c. A is nothing but the original counts from the weight I, and c is nothing but the truncated counts used for the dp to keep the state small, right? So I'll just go with too long. This one will be a equals new long of this one. Let's pass 9 here. Also long, this is also fine. C equals new long of this one 9, right? So this is fine. But one more thing, let's initialize the total to 0 first, right? So we are going with the total weight of all the items, right? So I'll just go with long total equals 0, right? This is fine. Let's go with let's move on with the iteration part here. So this one will be int I equals 1, I less than or equal to 8, I plus plus. So this is also fine. So within the for loop, what we'll be doing, so let's go with a we have to read the count of items of weight I, right? So this one will be a of I, that is equivalent to the long. So we have considered this one long, right? So this one we have to go with parse long instead of the parse int. So we have considered, as we have considered long, so string tokenizer dot, so let me go with the next token. So this is fine. Now after reading the count of items of weight I, so we have to accumulate the total weight. Accumulating the total weight in the sense we have to go with total equals total plus a of I into I, right? So this one will be total equals total plus a of I into I, right? So this is fine. The next step would be, after accumulating the total weight, so we have to truncate the count for DP accordingly with the approach. This one I had stressed, right? So we have to keep at most LIM by I items of weight I, right? So this is what I said within the approach, if you didn't understand at that point of time, right? So we have to truncate the count for DP, meaning we have to keep at most LIM by I items of weight I. LIM value, the smallest value that we have considered here is 840. We know this one, right? So let's truncate the count for DP. So this one will be C of I equals math.min of A of I along with LIM here. So this is fine by I. Yep, this is fine, man. Finally, let's remove the kept items from A of I, right? So nothing but A of I now stores the leftover basically. So this one will be A of I equals A of I minus C of I. This is fine, man. Right, now this is fine. Next, let's move on with the next step. So if total weight of all the item fits, then that's the maximum answer, right? So this one we had discussed in the approach as well. If total is less than or equal to W, then we have to print the total directly, right? So in simple terms, if I want to say this, if total weight of all the item fits, then that's the maximum answer. So let's try to articulate the same thing in the form of code. Nothing but total less than or equal to W. So then what we need to do, I'll just go with out.println. So we just have to print the total, right? So this is it, to print the total, right? So we have to skip this part. I'll just make use of the continue, right? So this is fine, man. Now yeah, we are done with this part. 1 second. Yeah, now let's do one thing. So we have to go with the base and picked, right? So base, because base is nothing but the minimal weight or the minimum weight we want to reach by greedy pick, so that remaining capacity is less than or equal to LIM, right? In the simple terms, when total is not less than or equal to W, then we have to move on with the base, right? Or the minimal weight we want to reach by greedy pick, so that remaining capacity is less than or equal to LIM. This one we have discussed on the approach as well. So let me go with here long base equals math.max of this one will be 0 comma W minus LIM. So this is fine. Now let me go with picked equals 0. This is fine. Now let's move on with the for loop. Let's move on with the iteration part. So this one will be for int I equals 1, I less than or equal to 8, and let's go with I plus plus. So within the I, so within the for loop, sorry, so I'll just go with the this one variable name use, because we have to compute how many of leftover items of weight I we can take without exceeding the base, right? So I can just write it on this way. See, long use equals, so I'll just go with math.min of this one A of I comma this one base minus picked totally divided by I, right? So this is fine, man. So now we have the idea. Finally we have to add their weight to the picked, meaning, so I'll just go with picked equals picked plus use into I. Basically we are done with this part, right? So I'll just come out of this one entirely. Now let's do one thing. Let's go with the DP array. As I've said, so we'll be making use of the DP for this, right? So we'll be going with the DP of ij, nothing but we will see whether we can achieve the total weight j using the truncated counts up to weight I. This one we have discussed this, so this one will not be that much difficult, right? So to implement, so this one will be boolean dp equals new boolean, this one new boolean of 9 into what we discussed, this one lim into 8 plus 1 we went with, right? So let's write the same thing, man. Let's see whether this works or not. If it doesn't work, then we can come here and change accordingly, right? Let's see. So let me go with 8 plus 1, right? So this is fine. Now so let's initially set the dp of 0 0 to true. This is nothing but the base case, right? So we are making use of 0 weights that we can form this one from the sum 0, right? So I'll just initialize dp of 0 0 to true, right? So this is fine, 0 0 to true, right? So let's go with the for loop here. So iteration part, so this one will be int I equals 1, I less than or equal to 8, I less plus, right? So within that I'll just go with one more for loop, int j equals 0, j less than or equal to lim into 8, so this is also fine, j plus plus, right? So within this for loop I'll just go with one more for loop. So 3 nested for loops right here. So this one will be int k equals 0, k less than or equal to iterated value of the c, and let me go with k plus plus. So this one will be int weight equals j minus I into k. This is fine. Now let's do one thing. Let's go with a simple if condition here. So this one will be if w greater than or equal to 0 and dp of this one I minus 1 w. So this is fine. Dp of I j equals, let me set this one to the true, right? So if by taking k items of weight I we can reach j, then we have to mark the dp of ij. This is fine. I'll just come out of this one, man, entirely, right? So let's go with a we have to go with the result variable, right? So anything result answer, we have to store this one, the solution within the result variable. So I'll just go with answer and initialize this one to the 0. Let me go with iteration part here. So this one will be long, w equals capital W, so this one will be capital W, and w minus picked, I think, right? So we went with this one. Within the approach we discussed the same thing, w greater than or equal to 0, and finally w minus minus, right? So this is fine. Now let's write the simple if condition here. If dp of this one from 1 to 8, right? So I'll just consider 8 here, dp of 8, so this one, and w we can just consider this one in the form of so let's convert this one in the form of int, man, just for the sake of optimization purpose. Int is enough, so this is fine. I didn't keep this one here, parenthesis, sorry. Yep. So this one, then what I'll do, let's assign the answer to this one, pick plus w, right? So this one will be pick plus w, right? Let me give break as well. This is fine. Let me give break as well, right? So I'll just come out of this one entirely. Now let's do one thing. So we have to print the answer, right? So this dp of 8, this one in w, so this one whatever I have written, answer pick plus w. So we are finding the largest achievable small w that is less than or equal to w minus picked, whatever I have made use of it within the for loop, right? So then the final answer will be picked plus w, quite obviously, right? So we will be going with, so here we have to print the answer. So this one will be out dot println of, let me pass answer here. This is fine. Finally what we will do, let's flush all the output. So either we can go with flush or close. I'll just go with a flush, right? So out dot flush. This is fine. We are done with the coding part, right? So we are done with the coding part. Before this one, checking the code with the different inputs, let's different inputs. Let's do one thing. Let me copy paste the signature starter template, man. Just so I'll just come here. Let me paste it over here. This is fine. I'll just come here. Let me copy this one. We have to get output 10, right? The same input we have made use of it within the approach as well. So we have the error here. Oh, this one has to be toString, not S2string. What line? Line number 39, right? So let me change this one very quickly. So let me remove this S. So yeah, we are getting the output 10. So that was the only error, I believe. So here we have to get the output 0. Let's check. So let me paste this one, third input, final input. This one we have to get the output 3. We are getting the correct outputs for all the 3 inputs, right? So that they have mentioned in the question. So let me tell you one thing. So these DP problem, right? This DP problem seems very easy after you understand or after you implement this one, right? So this one seems very easy, right? Only this much part of the code and we can just implement. We just have to know certain things and we have to implement, right? When they are given in the contest or when they are given this one, this is the biggest headache, right? The particular value you will get it only when you have solved certain problems within the DP, right? So this is to be frank, this is one of the toughest problems to implement, right? So I feel in that way. So DP, so you can just go with, you can just solve the graph problems easily. You can just solve any other this thing quite easily, right? So if you know the approach, you can just try to implement rather than the this one when it compared to the DP, dynamic programming problems basically, right? So it seems very easy, but implementation will be very difficult. I feel like that. So you can, after implementing, it seems very easy to write the code. After understanding, it seems very easy. I'm not going to say no, but to implement or to understand, that one will be very difficult. That's what I want to say. That's what I feel basically when it comes to DP, right? So yep, now we have the this one, what do we call, correct output for all the 3 inputs that I have mentioned in the question, right? So let me copy this one entirely, the code. Let me hit the submit button. Let me come to the submission part here. So this one we have already selected E. This is fine. Let me hit the submit button. So I hope this works for all the test cases, man. Let's see. Rating changes for the last round are temporarily rolled back. They will be returned. So okay, this is fine. Let's wait for some time. Yeah, running on 37:44. Yep. Yep, you can clearly see here in the this one, what do we call, toast, it is showing accepted, right? So the verdict that we got here is accepted. We have went with a pure DP to solve this particular problem, right? So we have went with a this one, Knapsack 01, right? So this one, basically this is pure DP, right? So we went with the DP to solve this particular problem, right? So this is fine, man. I hope the solution part is completely clear along with the approach and the complexities part. For now, this is it. Thanks for watching, guys.